In this video, I'm going to look at object-oriented programming for creating computer games in Pygame Zero. Now, object-oriented programming is a different style of programming from the procedural programming you may have tried before. It's about creating data and operations associated with that data, which is normally kept in separate program files to the main program. Makes it easier to understand the relationships. In this example, we're going to relate this to Pygame Zero. So I'm going to assume that you've got a basics of knowledge in Pygame Zero. But if you don't worry. There's some free resources on my website, and I'd suggest you go and look at these first. If you load up your browser and go to www.penguintutor.com. If you go on the projects page, you'll find information on my book here, Beginning Game Programming with Pygame Zero, and this will include an introductory video as well as some other videos, including this one. Or if you scroll down and find beginner's tutorial to create computer games using Python Pygame Zero. This is a very basic introduction into Pygame Zero. So let's say you might want to take a look at those before you continue on this, because this is going to be more looking at the use of object-oriented programming in Pygame Zero. The four main concepts are encapsulation, which is about keeping the internal state private to protect the data. Data abstraction, which is an extension of encapsulation, makes it easier to hide the details of internal operations to create simple, more stable interfaces. This means it's easier to change the code inside without breaking other things. Polymorphism, this allows a child to act as though it's its parent. This helps better code reuse through sharing and being able to use the code that's already been written, that's already been tested, but add your own features on it. And inheritance, which allows you to reuse parts of code between similar objects. Before we get started, I'll show you how to get the code that we're going to use for this. So this video is based on my book, which is Beginning Game Programming with Pygame Zero by me, Stuart Watkis. The source code, though, is completely freely available, even if you don't buy the book. So you don't need to buy the book to get to this and to follow this video. So from web browser, I'm running this on a Raspberry Pi. You could run this on other computers that have got Python and Pygame Zero installed. But in this case, it's the Raspberry Pi, which has everything you needed already on it, which is good. So if you just search for Apress, which is the publisher, and Beginning Game Programming Pygame Zero, which is just a slight shortening of the title, and hopefully the first result will come up with the main book page for the book. Here. If you just scroll down slightly, you'll see under the right hand side there's, under services for this book, a link that says source code, and that will take you to the GitHub page where the source code is. Now, so from, if you're not familiar with GitHub, it's a repository. You can download the code. You can also make suggested modifications to code and ask for a pull request and potentially update if you find any issues with the code. But for this, you can either go into the individual chapters and download the code. You can clone the whole repository, which means you keep a link to this, so if there's any updates, then you can get the latest version. Or you can click on download zip, and this will download the whole source code as a zip file. Gives you the option to sign up or sign in. You don't need to do that. You see it has already downloaded down here. If you just click on this, then it opens it in the X archiver, which is the zip program on the Raspberry Pi. And the code we need is just that in chapter 9. But you can just download the whole code. So we'll just extract all the code, and then we'll just copy the files that we need. Make sure extract files with full path is selected, and then just go to the home page. You could create your own directory, or if you wanted, I'm just going to just drop the whole thing there. And now you should see that there's folder beginning game programming with Pygame Zero. So the files we need are in chapter 9. And there's an images folder with the images that we're going to need, and these are all the source code. Just copy those. And I suggest you use the Mu editor because it's nice and easy to use. And therefore I'm going to put it into the mu underscore code folder. If you're using another editor, then you don't need to do this. You can put it in wherever you want. And you can just overwrite because there's nothing in there. And you'll see that the source code's been put in there, and then the images are stored in there. And these are, I'll explain these later, but these are images of scenes in the Lake District of the UK. So now we've got the files, I'll go into how we can create code using object-oriented programming and show some examples. As its name suggests, object-oriented programming is based around objects. In the real world, you can think of physical objects such as a ball. In the computer, these could be objects on the screen, like an actor or a sound, or it could be an internal object needed to keep track of the score in the game. In fact, much of the programming in Pygame Zero is interfacing with object-oriented classes, although you may not have realized it at the time. If you've created any games in Pygame Zero, you've already been interfacing with that object-oriented code. To create objects, we first need a blueprint, which is known as the class object. This contains the code from which the object is derived. And then we create instances of those objects, which are the objects themselves. This is best demonstrated using this diagram. So the class, which is, as I say, the blueprint, in this case is called ball, and it's got a capital B at the beginning. And this doesn't really exist. This is, or doesn't exist as an actual object that you can manipulate. It exists as a blueprint that can be used to then create the actual objects, which is shown in here. And here we show two actual objects, which are a red ball and a green ball. These are known as an instance of the objects, so they actually exist in terms of code. In this case, we're going to create one which will be called ball 1 and another one which is called ball 2. As you can see there, these look very different, or if you can distinguish between the colors, because one is colored red and the other is colored green. And these are the attributes that are individual to these particular balls. And this allows objects, although they're created from the same blueprint, to be different and to manipulate them differently. So I'm going to have a look at the code that will create this. So we'll have a look first at the ball class. So we've already loaded these into the mu directory. So if we go into the mu editor from the programming and mu, and if you load the file called ball.py. So this doesn't create anything on its own. This needs to be called by the game program, and that will then create an instance of this. And this is our blueprint. It's defined by the world class, which says this is a class, and ball, as we've seen. The capital B is a common convention to indicate that this is the name of the class. If there's any variables listed here, these would be the class variables, and these would apply across all instances, all the separate objects, not used as much as instance variables, which you'll see in just a second. The entry here, which is def, which normally associated with creating a function. In object-oriented program, this creates a method, and a method really is just a function, but it operates on the data inside this object. The init is called when you create or initialize the object to create the instance. All the methods refer to self. Self is a keyword that indicates that you're referring to this particular instance. You don't actually send anything on this parameter in the code when you call it, but it's defined there, and it allows you to manipulate this particular instance. And then this one has 3 arguments: a position, radius for the size of the ball, and the color of the ball. And from these, we've then got we've taken these values and we've saved them into as attributes on the self object, and this means these are instance variables or instance attributes that apply to this particular instance of this object. So they have their own position, radius or size, and color. Then we have another method, which is the draw method, and this again refers to the self because it needs to be able to refer to that particular instance, and it needs to be past the screen argument. This is because once we go outside of the main Pygame Zero file that's been executed, we're not aware of the screen, so we have to pass it to this method. And it just uses the same the screen draw filled circle that you'd use in Pygame Zero, and uses its instance variables for passing to the filled circle method of Pygame Zero. So this is the blueprint, but it doesn't actually do anything until we create these instances. We're going to load now. So the ball demo.py file is actually this is the program code. This is what is going to run this short demo program. So I'll go through this again line by line. So whenever we create our own classes, you have to tell it to effectively import them. But from ball, which is from the ball.py file, which is what we created earlier, just drop the .py, import ball, which is the name of the class. I put the usual variables for the width and height used in Pygame Zero. Again, these are the defaults, so you don't actually need these two lines, but I usually include those in any Pygame Zero games that I create. And then this is the line that creates the actual instance. Remember when we looked at the image, ball is the blueprint, the class, and we're going to create this instance here just called ball1. So we're going to say ball1 equals a ball, and this is going to create the instance of the ball class, and it's going to create it by calling this init method that we created here. We don't pass the self because that's implied by the fact that we're creating a instance. This is the first variable, which is the position, which is passed to a tuple. This is the second argument, which is the size or the radius, and then the color. We'll pass it the string red because that's a color that Pygame Zero is familiar with. And then once you've done that, the instance is created, it physically exists, or virtually exists in the running program, and you can use it. So in this case, we've added it to the draw function, which is automatically run by Pygame Zero, and we've given the object the name of the object, the instance of the object, ball1, and called the draw method, which is the method which is defined here, and given screen as the argument. The screen is already created for us by Pygame Zero, so we just need to remember to put that. Then if you click play, and there we go. So it's just created a small red circle in the center of the screen. So now I'm going to go back to the example. I'm going to create this second instance, ball2, and as you see, it will have a different attribute to give it the color green. So under here, we're going to create ball2, which is a object ball. We're going to put it in 100, 100 as the XY coordinates. We're going to make it bigger, so it's going to be 20 pixels, so you'll be able to tell which one is which, even if you're not able to tell the difference between the colors. And we're going to make this one green. And then we also need to tell the draw function to draw this ball2 as well as ball1. And we just need to pass that the screen as well. Just click stop to clear the message from the last run and play. So as you see, we've now got two different balls. Yeah. Now I'm going to change this ball1 to a different color. Now you could change it here, but also once you've created the object, you can manipulate any of its internal attributes, these self dot variables here, and we'll just change this color one to blue. So ball1, and then we're going to change its color to blue. And I mean, while we're at it, let's also change its size. So it's nice object. Radius. Make it even bigger now, so we can put 40. Let's clear that and run play. As you can see, it's changed in size and color on there. Now, it was still created as a red ball that was had a radius of 10, but then that was changed before the draw was run, so you never actually saw it when it was red and 10. It just runs straight away as blue and 40. So that's an explanation of a very basic first class that we can create in Pygame Zero. I'm going to get rid of that. I'm going to just delete those files that we've just been using. You don't need to do this, but just make it a little bit clearer when we move on to the next program, because the rest of the files are the ones we need. Before we move on to the next game, I'm going to look at what inheritance is. So I've got another picture here that's going to describe this. And in this case, I'm going to use an example of an airplane, which could be included in a game. And we've created a parent class called airplane. And this covers everything that you expect a typical airplane to do. In this case, we're just showing a few of the attributes and methods. For instance, all airplanes would have a number of engines and have the ability to, and then the methods are the ability to take off and to land the plane. Otherwise, wouldn't be very much use. However, in this scenario, we're looking at a few different planes, and there might be that you want to create a passenger airline, a passenger plane, or a cargo plane, or a fighter plane. And these are clearly all different types of planes, and they've got different needs and requirements, but they still have this same basic basic attributes. They all have a number of engines. They all have the ability to take off and land. So rather than defining those separately for each one, we can take those from the parent class. However, each of these then needs to have their own ability to do things. For instance, the child class, in this case, the passenger plane, is going to have passengers. So you have a number of passengers, and you need the ability to load and unload passengers. In the case of a cargo plane, then we don't have passengers, instead we have cargo. So in this case, we could have an attribute which would be the cargo capacity and the ability to load and unload cargo. And otherwise, with a fighter plane, you wouldn't need any of those, but it might need missiles and to be able to load and fire its missiles. And this is how you can create code within the parent class, and then the children classes can extend that functionality as they need it. So just to explain this, because this is a feature that we're going to use when we start creating children in the next program. So that's the theory bit out of the way. We're going to jump forward into the game. And this, we're going to create, or have created, a memory game. This is a classic memory card game, which you may have played as a child, sometimes called matching pairs, where you have to turn over 2 cards at a time and trying to get a matching pair. In this version, we're going to be played against a timer that's going to run, and we've got so long to clear the board. In my book, then in a later chapter, that is then updated to play against a computer opponent using some simple artificial intelligence. But at the moment, it's going to be just using a timer. In the book, then I have explained about the process I use to determine what classes I created. But here we're going to just jump straight into the code. And the different classes I've created are a timer class, which is going to control the timing of the game, a card class. This is a child of an actor class, and this is going to handle displaying the cards. A gameplay class, which is used to separate the tracking of the game state and the scoring from the main program. And then memory.py. This is not actually object-oriented because the way that Pygame works, looking for the draw and update functions, but then it will make use of the other object-oriented programming style classes. So if we go to new, and we can load these up. I'll load these one at a time. We first start with the timer class. So this is a simple class that's just going to run a little timer, and so that we can count down the time used. So I won't go into these in quite as much detail as I did the previous one. I'll skip over some of these. It uses both the math and time libraries, so they're a standard Python libraries that you can make use of. Creates a class called the timer. This is the initialization method that is called every time that it starts. In this case, it's just got the one argument, which is the counting timer, but it's also so start count is a variable that says what the value should be of the counter when we start, because it's going to start at that value and count down. The second isn't passed by the argument. Instead, it uses the time function to get the current timestamp, which it stores in an instant variable. This way, it is able to look up what time and what the current time is and what the difference is between when the timer was started. Now, in this case, we're only going to create one instance of the timer class, but the same principles still apply to the object-oriented programming. We've got a method which we call when we want to start the timer, and a method to find out how much time is remaining, and there's just some simple bits of code there which determines how long we've got left. It does use the math.ceil value. This is a method that performs rounding of a number. The two corresponding ones, math.floor rounds down, math.ceil rounds up. So in this case, it's going to round up the current time and return that. So that's a very quick overview of the timer class. Really, if you want to figure out what it does, you spend a bit of time looking at it, and it's only 20. Yeah, it is only those 22 lines of code. So you should be able to, with a bit of Python experience, be able to work out what that does. So the next class we're going to look at is the card class, and this is the main class that is going to handle the object-oriented programming and create each of these cards that we're going to create. And particularly this is the part that is very specific about how we do object-oriented within Pygame Zero. So because we're outside the main program file, we're going to take a step back. So this is going to create an actor. So in Pygame Zero, an actor is a sprite or an image that's going to be put on the screen. And we wanted to create a child class. So if you think back to that plain example, the top level is the actor. Every actor would apply to that. But in this case, we've got a more specific type of actor called a card, which is going to have some extra methods like the ability to turn the card over and so you can see the front or the back. Because we're outside the main program file, because remember I said that the main program file is going to be memory.py. If we're in that, then Pygame Zero automatically loads all the libraries we need. We're outside of that, so we need to import the actor from Pygame Zero.actor. We just need to include that as the first line. Then, as we created classes before, we call class and give it a class name. In this case, there's what looks like an argument inside the brackets. In this case, this is saying this is going to be based on an actor class. So we're going to create a child class of the actor. We create the init method, and you'll then see that we call actor.init. Now, in the case of creating a child class, if you want to inherit the init function from the parent, you have to explicitly say it. And this is how we do it. So in this case, it's going to say also run the init from the actor, our parent class, and pass it a couple of parameters. In this case, one of them is taken from the arguments that we've been passed, and the other one is a variable of a tuple of 0, 0, because that is the position, but we're going to manipulate that later. So it's just putting it in as a placeholder effectively. And then we can carry on with this init method as before, in this case, saving these values as our instance variables. And we set one here, self.status equals back. We set it so that it's showing the back of the card rather than the front. And that's another instance variable that we can manipulate. We create the draw method as before. In this case, we've got one extra test first. We say if the card is hidden, then return. This means we're going to return from this method. We're not going to run the next line of code. If we do, then again, as we did before, we're going to run the parent draw method. So this one is actually overriding the parents method because it has one already, but we still want to make calls to it. So we're going to call the parent method. We've got a method here that turns the card over, and basically it looks, are we showing the back? So show the front, and vice versa. We've got methods that allow us to hide or unhide the card, show whether it's hidden, it's face up, and various other methods there. So basically in this case, we inherit some of the methods. We add our own, which are these ones below, which the parent has no knowledge of the ability to unhide and hide, for instance. And in this case, we override the draw method. So although our parent has a drawer, we get our own drawer, but we also make a call to that drawer if we want to show it. So the next file is gameplay. Okay, so in the gameplay file, we have a few entries at the top that effectively these are constants. Now, Python doesn't actually have a differentiation between a variable and a constant, but by putting these in capitals, we're indicating that we're not going to change these. These are just so that we can refer to these later instead of having to remember that 0 means we're in the new state, or 1 means we're in the player 1 start state. We can use these names that make it a bit easier to understand. After those, we've got the class definition. So we created this as a class. We've got the init as before. The instance variables are all ones that we set separately. And really, this has the ability to, so we can check whether we're in a new game, whether we're game over. And you'll see this when we, in the actual game file itself, it needs to know about these states to determine whose go it is next and things like that. And obviously this gets more important when we move on to a future version where we've got a second player. And really they're just checks, checking to see what state of what state of the game we're in. And then the last one is memory.py. And this is actually the game itself. So this is the program we're going to run. And this one is not a object-oriented file itself. This is the called by Pygame Zero, which is looking for specific functions. So we need the random number generator to be able to create, to order the cards in random positions. We've got some constants that determine whereabouts the cards are going to be placed, how many cards per row, etc. Some Pygame Zero setup constants there. Then a list, which are actually a dictionary, which is the different cards that we're going to load. And this is where we're actually creating the instances of the cards. So instead of naming them individually, ball 1, ball 2, as we did here, in this case we'd have card 1 to 12 or whatever. What we're doing is we're just creating the individual cards and saving them in a list. And this all cards is a list. So it'll start with adding for every one of these cards that we've got available, which is these, it adds 2 copies because this is a pairs game. Obviously we need two cards of each pair. And it just creates all the instance variables. The deal cards function here will use random.shuffle to shuffle all our cards so they're in a random position, and then based on their position it sets their position, which means it sets their XY location on that on the grid. The update function is one that's required by Pygame Zero, or is provided by Pygame Zero rather. And in this case, it just checks what state of the game we're in. These aren't actually used at this point in the game, which is what the pass means. It's just ignore them. but they're used when the game is developed further over. So really they're just placeholders. But if we're not in new game, we're not in game over, then this is the important thing. It updates the timer and then or checks to see if we've run out of time and the game is over. It uses the Pygame Zero mouse down to determine whether a card is clicked and then what actions to take on that card. It uses the draw function. This one there said end level reached if we reach the end of the level, which means that all the cards are hidden, and this will return true. If there are some cards that are not hidden, then it knows that we need to keep playing. And then the draw function, which is a standard part of Pygame Zero, fills the screen with color. If it's a new game, then it gives a message. If it's the end of the game, then it gives a different message to say that the game's over. And if not, then it displays what cards we've got left, as well as telling you the remaining time and the score. After all our functions, then we've got deal cards, a call to the deal cards function, which is the function that randomizes the cards. This needs to be after the function it's calling, so that's why it's right at the very bottom of the file. And should be able to just play this game. You see, gives you the message at the start. And these are our cards, and we've got to turn them over looking for a pair. If we don't find a pair, then keep going. So, oh, I remember seeing that one. There we go. We scored 1 point, and the timer keeps counting down. Oh, I did see that. That's up there, but I'll just keep going on. That was that one, rather. That one. And you just keep going, looking for matches. And if you manage to clear them before the time runs out, then you get another go. If you run out of time, then game over, and it gives you its score. So this game's a little bit more complicated than the ones I've shown in the previous video. Certainly a bit more lines of code, but I think that the fact that this is broken down into object-oriented programming, you can go inside the card, particularly the card class is relatively small, but allows you to check the status of the card, helps reduce the amount of code that's in the overall game, and makes it a little easier to follow. So hopefully that has given you a bit of an idea of how we can use object-oriented programming within Pygame Zero. So thanks for watching. You can buy my book if you want to find out more about this, and a more detailed explanation in the book about how this game is created. Or if you want some free resources, then if you go to my website, penguintutor.com, there's more videos and demonstrations about creating games in Pygame Zero. If you enjoyed this video, please click on like and share. Let me know what you think of it in the comments, and subscribe to my YouTube channel to find out when my next video comes out. I hope to add videos on creating a computer opponent using simple artificial intelligence, and demonstrate the final game, which is a space shooter game designed for an arcade machine.